Okay, so it says postal regulations specify that a parcel sent by parcel post may have a combined height and girth, which is the distance around, not exceeding 50 inches. If a rectangular package has a square cross-section where L is equal to W, the length is equal to the width, find the dimensions of the package with the largest volume that may be sent through the mail. Okay, round your answers to 2 places. We have to think what we're trying to maximize, and I guess we go to our question. So the largest volume, so we're trying to maximize volume, and this is a box, sent through the mail, right, a package. Okay, so maybe something like this. This is the length, this is the width, and this is the height. Length, width, and height. Okay, now it does say a combined height and girth, 2W plus 2L, not exceeding 50 inches. So the height and girth together, like when you add those together, that should be 50 inches total. Okay, so let's make that into an equation. H plus 2W plus 2L. Okay, so that 2W plus 2L, if you think about where that is on my box, that's just the perimeter of one of the bases, right? Okay, so H plus 2W plus 2L is equal to 50. Okay, next, we want to find the volume, a maximum volume. So length times width times height is the volume of a rectangular prism like this. So I have to go back up to this information that's given. The cross section, it is a square. L and W are the same. So we're going to replace, doesn't matter which one, replace W with L or L with W. Okay, so we get H plus 2W plus another 2W. I just replaced L with W is equal to 50. And combine, so that's 4W, so H plus 4W is equal to 50. H is equal to 50 minus 4W if I isolate H. Okay, so now we can go back over to this other equation, the volume, and let's see, the length and the width are the same, so L becomes a W. And then the W is still there. And the H now in terms of W is 50 minus 4W. And if we distribute, let's see, that's W squared times 50. So 50W squared minus 4W cubed. And here is the formula for our function, where volume is a function of the width of this box. Hey, once we found that information, our goal is to maximize. So we need to take the derivative and find that critical value or critical values where a max or min may occur. But in this case, we're looking for a max. So V prime is equal to the 100W minus 12W squared. Okay, you're then going to set V prime equal to 0. And, try to factor. Does that sound good? So I want to factor out the greatest common factor from those two terms. 4W, is that good? And so we get 25 minus 3W. Is that correct? So 4W times 25 minus 3W, and then set each factor equal to 0. W is 0. The other one, set this other factor equal to 0, and we get 25 minus 3W equals 0, so W equals 25 thirds. Now it does say we can round our answer to 2 places. So I could just say, well, 25 thirds is 8 1/3, so 8.33 rounded. Now, if that's W, the length is exactly the same. Okay, so there's 2 of our answers. W, 8.33, L, 8.33, and then lastly, H, we have this relationship between W and H. If I use the 25 thirds, which I think would be the better bet, right? 25 thirds. I get it's 16 2/3. So 16.67